99% confidence level. GPS time is accurate to about 40 nanoseconds. Higher accuracy available today by using GPS in combination with augmentation systems. These enable real-time positioning to within a few centimeters. GPS signals. Firstly, acquisition code, precision code, navigation message, almanac, data updates. GPS frequencies. You can see what are the frequencies of GPS. L1 is 1575.42 megahertz, L2 1227.60 megahertz, L3 1381.05 megahertz, L4 1379.913 megahertz, L5 1176.47 megahertz. Frequency information. The C/A code is transmitted on the L1 frequency. The precision code is transmitted on both the L1 and L2 frequencies. L3 is used by the Defense Support Program to signal direction, the signal detection of missile launches, nuclear detonations, and other applications. L4 is used for additional correction to the part of the atmosphere that is ionized by solar radiation. L5 is used as a civilian safety of life signal. Frequency L2C. It was launched in 2005. L2C is civilian GPS signal designed specifically to meet commercial needs. L2C enables ionospheric corrections, a technique that boosts accuracy, delivers faster signal acquisition, enhanced reliability, and greater operating range. L2C broadcasts at a higher effective power, making it easier to receive under trees and even indoors. Sources of GPS signal errors. Different errors can cause a deviation of plus minus 50 to 100 meters from the actual GPS receiver positions, which are firstly satellite clock, receiver clock, and GPS jamming. Satellite clock. 1 nanosecond of inaccuracy in a satellite clock results in about 30 centimeters of error in measuring the distance to the satellite. Secondly, receiver clock. Any error in the receiver clock causes inaccuracy in distance measurement. However, it is not practical to equip receiver with very accurate atomic clocks. Atomic clocks weigh more than 20 kilograms, cost about US $50,000. GPS jamming. Thirdly, GPS jamming. It limits the effectiveness of the GPS signal. GPS jammer is low-cost device to temporarily disable the reception of the civilian code's acquisition code. Atmospheric errors. Speed of GPS signal is affected by ionosphere and troposphere, which cause a deviation of 0 to 30 meters from the actual position of receiver. Fourth, multi-path error. Bouncing of GPS signal due to a reflecting surface before reaching to the receiver antenna, which cause a deviation of 0 to 1 meter from the actual position of receiver. Methods of improving accuracy. Precision monitoring, dual frequency monitoring. Secondly, carrier phase enhancement. Thirdly, relative kinematic positioning. Augmentation. A dual frequency monitoring refers to the systems that can compare two or more signals. These two frequencies are affected in two different ways. After monitoring these signals, it's possible to calculate what the error is and eliminate it. Receivers that have the correct decryption key can decode the PY code transmitted on signals to measure the error. Career Phase Enhancement (CPGPS). CPGPS uses the L1 carrier wave, which has a period 1000 times smaller than that of the CA bit period, to act as an additional clock signal and resolve uncertainty. The phase difference error in the normal GPS amounts to between 2 and 3 meters of ambiguity. CPGPS works to within 1% of perfect transition to reduce the error to 3 centimeters of ambiguity. By eliminating this source of error, CPGPS coupled with DGPS normally realizes between 20 and 30 centimeters of absolute accuracy. Relative kinematic positioning (RKP). Determination of range signal can be resolved to an accuracy of less than 10 centimeters. Resolves the number of cycles in which the signal is transmitted and received by the receiver, accomplished by receiving a combination of DGPS correction data, transmitting GPS signal phase information, and ambiguity resolution techniques via statistical tests, possibly with processing in real time. Augmentation relies on the external information being integrated into the calculation process. Some augmentation systems transmit additional information about the sources of error. Some provide direct measurement to how much the signal was off in the past. Other group could provide additional navigation of vehicle information to be integrated in the calculation process. Augmentation system. Nationwide Differential GPS System (NDGPS). Ground-based augmentation system that provides increased accuracy and the integrity of GPS information to users on US land and waterways. The system consists of the Maritime Differential GPS System operated by the US Coast Guard and an inland component funded by the Department of Transportation. Wide Area Augmentation System WAAS. Satellite-based augmentation system operated by the Federal Aviation Administration FAA, supports aircraft navigation across North America. Global Differential GPS GDGPS, high accuracy GPS augmentation system developed by the NASA Jet Propulsion Laboratory JPL to support the real-time positioning, timing, and determination requirements of NASA scientist missions. Future NASA plans include using the Tracking and the Data Relay Satellite System TDRSS to transmit via satellite a real-time differential correction message. Now, limitations. GPS can provide worldwide three-dimensional positions 24 hours a day in any type of weather, but there must be a relative clear line of sight between the GPS antenna and 4 or more satellites. Hence, it becomes too difficult to ensure reliable positioning. These difficulties are particularly prevalent in urban areas. The GPS signal may bounce off nearby objects, causing another problem called multipath interference. Application. First is the surveying. Secondly, telematics. Vehicle tracking. Locate your vehicle anytime, anywhere in this world. GPS car tracking system is more effective way to locate a car. Monitor, track, spy. Exact location on the map, speed at which the vehicle is traveling, total distance traveled by the vehicle, fuel refill, theft, ignition control of the vehicle. You can see that how does it work, and you can see the diagram on your screen. Applications. Military. GPS integrated into fighters, tankers, helicopters, ships, submarines, tanks, jeeps, and the soldiers' equipment. Target tracking, search and the rescue. Conclusion. GPS is a satellite-based navigation system that can be used to determine the position of an object on Earth. This application field is vast and new application will continue to be created as the technology evolves. The GPS can also interfaced with other similar projects such as EU's Galileo, Europeans Galileo, to account for unpredictable applications. Thus, the GPS constellation like man-made stars in the sky can be used for guiding and navigation. So guys, thank you for watching this video, and you can subscribe my channel if you like it. It is a thankful goodbye by Gaurav Gauri. See you next time. Goodbye.